Welcome back, everybody. We're on day 11, May 13th. It's Wednesday. We're almost done with the week. We're more than halfway. We got page 21 and 22. We're in the middle of this scenario week where we just splash an example and then you try to figure out and make sense. Independent, dependent, okay? If you had a chance, there were two videos I posted today. Independent and dependent, okay? It's only a 2-minute video. Draw something out. If you put it back, it's independent. If I pull it out and I don't put it back and then I draw, dependent. Possible outcomes. Given a scenario, can you see what the possibilities are? 52 cards in a deck. 52 times, right? Okay, let's check some scenarios out. Today we have page 21 and 22. And we have a total of 6, 6, and 2. 6, 6, 2. 14 problems, okay? I want to do 4 of them because each one has a little twist to it. All right, let's start out with problem number 1. Poof. Show all the different 3-digit numbers using a 4, a 5, and a 6 where each digit is only used once. Okay, lots of different ways to think about it. One of the most popular ways to illustrate it, to draw it, is to use a tree diagram, okay? So let's draw a tree diagram. We got a 4, we have a 5, and we have a 6. What are all the possible combinations? Well, you can only use it once. Now remember to read the words, only use the digit one time, okay? Well, if the 4 is gone, that leaves a 5 and a 6. If the 5 is gone, 4, 6. If the 6 is gone, 4, 5. Now remember the rule, 3-digit number. Tree diagram. Boom, 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 boom. 4, 5, 6. 4, 6, 5. 5, 4, 6. 5, 6, 4, 6, 4, 5, 6, 5, 4. Now remember, the beauty of a video is you can come back and watch it. You could pause it if you want. Now, going back into our notes, you remember our note page? Don't forget the note page. We're going to fall back to our notes when it comes to doing the high-level math next week. But we can count. This problem. Total number of possibilities. There's 3 items here, 2 items here, 1 item here. If you go back to the note page, I introduced the idea of the FCP, the fundamental counting principle. 3 times 2 times 1. There's 6 possible combinations. 3 times 2 times 1. Count the branches on the tree. 1, 2, 3, 4, 5, 6. Isn't that cool? All right. That's problem number 2. Excuse me. Problem number 1 on page 21. All right. Now, each one of these has a different twist to it. I want to go to number 4 because in probability, we always come back to flipping the coin. Flipping the coin. What is the chances of getting a heads? What is the chances of getting a tails? In problem number 4, what are the possible outcomes for flipping a coin 3 times? Flip it, head, tail. Flip it, head, tail. Flip it, head, tail. How do we draw something like that? Again, a tree diagram really helps to illustrate it. So, problem 21. Flip a coin. Head, tail. Now we got to flip it 3 times. If the first time we flipped it, we got a head, then the second time we flip it, what are we going to get? We could go H, H, or HT. If we flip the tail, then the next time we flip it, H or a T. See the possible combinations? First we had 2, and then it doubled to 4. When we do it the third time, what's going to happen? Can you see it? 2, 4, 8. Can you visualize that? Head, tail, head, tail, head, tail, head, tail. That's what I want you to spend your time on today. Remember, 20 lessons, 20 days for 20 minutes. Try to visualize. If you don't get to all the problems, that's okay. But take a minute. I love the tree diagram because depending on how it was written, each digit used once. What are the possible outcomes of flipping a coin 3 times? But each time you do it, there's 2 possibilities. 2, 2, 2. Okay? So now, how many were there? 2 here. Then it doubled. Then it doubled. Can you see it? 1, 2, 3, 4, 5, 6, 7, 8. 8 possible. 2 times 2 times 2. The problems look similar, but after you draw them, one is multiplying 3 times 2 times 1, and the other is 2 times 2 times 2. Awesome. Now we're going to flip the page and do more probabilities. I'll see you in a minute. Okay, thanks for coming back. Now, we were going to do 2 more problems today. Each problem had a little twist on scenario week. What can you visualize happening? Okay, so we turn to page 22, the very first problem, E number 1. Finally got to a spinner problem. It's like a clock. Okay, got 12 pieces of pie, 12 pieces of pizza. Okay, what's the probability of greater than 7? Don't overthink it. Greater, greater than, not equal to. From here to here. That's 1, 2, 3, 4, 5. Okay, probability greater than 7? 5. Probability greater than 7. The probability greater than 7 is 5 of 12. Done. Probability not greater than. Not. Okay, not greater than 7. 7 out of 12. Probability less than or equal to 7. 7 out of 12. Done. Poof. See ya. Okay. Each one of those has a little twist to it. Don't overthink it. Okay, it either is or it isn't. Okay, all right. Now, F, this counting principle. Okay, remember the counting principle. 3 times 2 times 1. You saw it just a moment ago on the other page. It's in your note page. 3 times 2 times 1. 4 times 3 times 2. So problem number 1, F1, wow, it's a big number. You can't possibly write them all out. 5 times 4 times 3 times 2 times 1. Okay, all right. Let's look at number 2. These are really popular problems in statistics, and they're real world problems. Okay, if you go to Anthony's Seafood down by the river, okay, they have the pick 3, right? If you go to McDonald's, they got the pick 3, where you can choose from 3 categories. Okay, we're going to go eat lunch. And there's different types of sandwiches, okay? So we got cheese, chicken, ham, turkey. For soup, minestrone, chicken noodle, vegetable. Drinks, cola, tea, coffee. What are the possible combinations? Okay? Fundamental counting principle. Okay? We have these groups. There's a group. There's a group. There's a group. The answer is 4 times 3 times 3. But let's try to visualize it. Here's a tree diagram version. Can you see how we have cheese to the minestrone? Once you get to the minestrone, 1, 2, 3. Try to visualize. If I order a cheese, a minestrone, then I get coffee, tea, cola, tea, coffee. All right? Now, this item has 3 possibilities. Boom. This item has 3 possibilities. This item has 3 possibilities, the 3. Now, if I have the cheese, 3 times 3. Each one of these has 9 possibilities. Poof, poof. But there's 4 main items. So this one will have 9, this one will have 9, this one will have 9. So the final answer is 4 times 3 times 3. Got it? Good. 36 total possibilities. Okay? So again, scenario week, no formal math, trying to get you to visualize all these different scenarios. Okay? 2 minutes, 2 minutes. This video was 9 minutes. Okay? We're good to go. You got 7 minutes. You can try every problem. We're winding down. If you looked ahead, tomorrow there's only one problem, and then it's a daily doodle. Whew. We survived scenario week. Okay? So have some fun. Hopefully you'll reach out and we can talk to each other. You can show me what you've done, what you're experiencing, how's life going, or ask me for some help. And I'll see you tomorrow on day 12, which is Thursday, the last math day of the week, and I'm asking you to do a daily doodle. See ya.